Dear students, welcome to the course of the Computer Network Management. Before we proceed on to the Network Management course, we will have the following course contents, which are related to Introduction to Network Programming, Direct Link Networks, Packet Switching, Internetworking, End-to-End Protocols, Congestion Control, End-to-End Data and their applications. So first of all, we will see what is a network and what are the basic requirements for a network design. What we normally see is the network is a set of serial lines which are required to attach terminals to a mainframe computer. These networks can be a telephone network which carries voice traffic. It can be a cable network which carries the video signals, and it can be any type of network in which we have connections of different devices through cables. Now, what distinguishes a computer network? Either it is the generality or special purpose programmable hardware. And the third thing is what sort of applications are being supported by any network. So first of all, let's see the applications. We have thousands of consumers on networks today, and if they make a single click, several messages are exchanged over the internet. For example, if we just type HTTP, Hypertext Transfer Protocol, 17 messages are exchanged. These 17 messages are broke up into the following categories: 6 messages for the translation of the server name, 3 messages to set up a TCP connection, 4 messages to send HTTP response, and then 4 messages when we want to break the connection. Millions of messages are exchanged every day on the internet by different consumers, which we can see in our daily routine life. Now, why we use the networks? The main question. The thing is the applications. Applications are the driving force for any internet or internet application, because if we don't have any sort of applications, then don't you think that we will be able to use the internet so frequently as we use it today? Now, these are the different examples of applications, like streaming audio and video, which is an emerging application today. Similarly, video on demand, which reads a pre-existing movie, that is a one-way data transfer. The movies are stored on the servers, and anyone by using this application can see his or her own movie as per desire. Other thing is video conferencing, which are in interactive sessions. People are sitting at their homes as these days, and they are in contact through video conferencing with each other. Diversity of applications that can be built on top of the internet hint at the complexity of the internet design. Now, this means that the students, the users, the applicants, they are normally not aware what complex applications are being running behind these applications. The user is unaware of the complexity because the things are much more complicated when running at the back end. So on the front end, we don't want the user to be so much aware of these things. He or she should be only able to use the application. Now, coming to the next overview of the network. What we expect from a network, what it should provide: connectivity, cost-effective sharing, functionality, and performance. So what do you mean by connectivity? Connectivity means that if we are designing a network, or if we want to run a network, or we want to run an application on the network, it must be connected. Now, we see in our normal routine lives, when a connection is made and it suddenly breaks, it makes and breaks. So that is really problematic. That is really embarrassing, and people face problems when such type of connectivity issues come. Now in normal routine life, when we are using any mobile application as well for 3G, 4G, 5G applications, we want the networks to be connected. The other thing is, which is very important, is cost effective sharing. Now cost effective means that as the networks are growing, the applications are growing, more and more people are being connected. We want that the network must be cheap, the connections must be cheap, the application must be cheap. Cost effective sharing. As we all know that in older days, when we had to make a call to any foreign country, then the cost of that single call was too much high. But for today's world, using the WhatsApp and Skype and Messenger and all these applications, the things have become very cheaper, much cheaper as expected. Third thing is functionality. A network, if designed for something, it must provide that functionality. For example, we see that if we are using an application like Facebook or Instagram or WhatsApp, then the network must run that application. It must perform up to the optimum level. We want the network to provide its best. Now, how are the networks designed and built? They are designed by layering, using protocols and standards. So what is the difference between these three? First of all, layering. We all have heard about the OSI layer architecture. This is a 7-layer architecture, and each application is being performed on its own layer. When we move on from layer to layer, from the bottom layer to the topmost layer, each layer is assigned its own duties and it is performing its own functions. So similarly, whole network world is functioning on layering applications. On each layer, we see number of applications being run, and when these applications are run, they need some protocols. Now protocols means set of rules which must be followed if any application is to be run. If these protocols become a benchmark for other protocol applications, then they are called standards. Next thing is perspective. Every human, every user, every consumer, every applicant who is using a network will have its own perspective. These perspectives can be categorized into 3 categories: a network user perspective, network designer perspective, and network operator perspective. So when we talk about the network user, what he demands, that is the connectivity. For any services required, he wants error-free delivery within acceptable time limits. For a network designer, we need efficiency. The designer wants a cost-effective design, fair allocation, and efficient use of resources. Now, fair allocation means that if 10 users are connected to a network, each user should have equal bandwidth, equal use of resources. If a printer is connected in a lab of 40 persons or 40 people working on them, then everyone has the access to that printer or server, whatever the resources are available. The third perspective is of the network operator. He needs maintenance, easy to administer, fault localization and isolation, and usage accounting. Now maintenance means that if, for example, we have 40 or 50 computers connected to a server and suddenly one system stops working, then a network administrator who is sitting in his office, he should be